All right, so now it's time to divide polynomials. And dividing polynomials is just like, well, almost just like dividing integers. So let's do a divide integers problem and remind ourselves the process because we're going to mimic it when we start to divide polynomials. So if I have 516 divided by 12, I'm going to set it up in a long division structure. So I'm going to divide 516 by 12 and then do long division on this. So does 12 go into 5? No. Does 12 go into 51? It does. It goes in exactly 4 or almost 4 times. So that means if I multiply 12 by 4, I'm going to get a number less than or equal to 51. Then I want to multiply 4 times 12 to get 48. And then I need to subtract 48 from that 51 to get 3 and bring down the 6. Then I start all over again. Does 12 go into 36? It does. It goes exactly 3 times. So then I multiply 3 times 12 to get 36. And when I subtract this time, I end up with a 0. I have a 0 remainder. All right, so that should have been redundant for you. You've done this a lot of times before. I just wanted to really delineate the steps that you ask yourself, what can the divisor go into? How many times can the divisor go into parts of the dividend so that you can break it down into little tiny pieces rather than having to just figure out how many times does 12 go into 516. So this is long division of integers. We've done this 1,000 times, but now we want to use long division of polynomials. And so I'm going to demonstrate that by making an example or using an example. So we want to take 3x minus x minus 2, clearly a trinomial, a polynomial, and I want to divide it by x minus 1. All right, so it's exactly the same thing as this. I changed from a division symbol to a division bar, no big deal, but I want to use polynomial long division. So this is integer long division. Right? And I'm going to use now polynomial long division. Which is almost exactly the same thing as integer long division, except it has a couple little differences that accommodate the fact that a polynomial is not an integer. So first, I want to set it up exactly the same way. I'm dividing by x minus 1. And the thing I'm dividing by x minus 1 is 3x minus x minus 2. And so I start off in exactly the same way, except I'm not asking how many times can x minus 1 go into 3x or x minus 1 go into 3x minus x. I'm actually just going to, with polynomial long division, I'm just going to look at the first part. And the rest of this is like a tail that trails along. And we just follow the rest of it along to see. We just let it follow along. All right, so that'll come a little bit clearer when I start to do it. So what would I have to multiply x by to get 3x? I'm sorry, I miswrote this. This is a square. What would I have to multiply x by to get 3x squared? Well, x times 3, right, would be 3x, and x times 3x would give you 3x squared. And then just like I did before, we're going to multiply whatever that number was I got by the divisor again. So that means 3x. Now I'm multiplying a number with 1 part to a number with 2 parts, so I have to do 2 parts. So I have 3x times x equals 3x squared. This always has to be exactly the same number. For long division in polynomials to work, it has to be exactly the same number. With integers, we didn't need exactly the same number. When we did our subtraction, we just kept working with what we got. But with a polynomial, it has to be exactly the same number. So I have 3x times x, 3x squared. 3x times negative 1 minus 3x. Cool. Now exactly the same thing we did before. We're going to do subtraction. So I'm going to subtract this number from the number above. Now what I'm doing is I'm subtracting 3x squared minus x. From 3x squared minus x, I'm subtracting 3x squared minus 3x. And remember, when we did this, we had to change the signs of everything inside to get rid of the parentheses. We're doing the exact same thing. This minus tells me to change all the signs inside. So I'm going to turn this one into a minus. I'm going to turn this one into a plus, and now I can add them, which is exactly what we did when we did subtracting polynomials before. So now that I can add them, 3x squared plus negative 3x squared, this cancels. And because these are always going to be the same number, this first term should always cancel. Now I can combine my x terms. Negative x plus 3x is 2x. And then just like with integers, I'm going to bring down the next part. So I have negative 2. I'm just going to bring that negative 2 down. Okay, same thing. Now that I've got a 36, I start again with my 12. How many times does 12 go into 36? Only in this case, I'm looking at how many times does x go into 2x? Or what would I have to multiply x by to get 2x? Well, x times 2 would give me 2x. Now let's double check my work. I'm going to multiply 2 times x to get 2x. Yay, I got the same first number, so I know I picked the right value. And then just the rest trails along. 2 times negative 1 is negative 2. Perfect. When I subtract, that means I have to change the signs of everything inside and turn it to addition. 2x minus 2x disappears. Negative 2 plus 2 disappears. I'm left with 0 for the remainder. So I can say that 3x squared minus x minus 2 divided by x minus 1 equals 3x plus 2. So that's polynomial long division. All right, so let's do a couple more examples now that we have the basic structure. And actually, the next example is going to be a little bit easier than the one I started with. We want to take 6x cubed minus 12x squared plus 9x. And I want to divide this number by 3x. So this time I'm dividing a trinomial by a monomial. Doesn't matter. It works exactly the same. So I have one caution that I have to watch out for. I have to represent every degree of the variable after the first. So this is a 3 degree. This is a 2 degree. This is a 1 degree. And I'm going to have to allow for there to be a 0 degree polynomial or monomial or term. So I'm going to do that by just using a 0. So I have 6x cubed minus 12x squared plus 9x, and then I have to add 0 x to the 0 power. So I need a constant term. I don't have a constant term in this number, but I need a constant term in my dividend. So I automatically put in zeros wherever I don't have a term represented in my actual number, a placeholder, if you will. And I'm going to divide that by 3x. So question is, what would I have to multiply 3x by to get 6x cubed? Well, let's start with the sign. A positive times a positive would give me a positive. So I'm going to start with a plus. And I'm not going to write that because I don't need a positive in the very beginning written down. 3 times 2 would give me 6. So I move on to the numeral. X, I have 1x. I need 2 more x's. Great. Now let's multiply. So 2 times 3 is 6. X squared times x to the first is x cubed, and I don't have anything trailing along. That's okay. I'm just going to do my subtraction, take what I get. These cancel. Bring everything else down. Start again. What would I have to multiply 3x by to get negative 12x squared? Well, a positive would have to multiply by a negative to get a negative. 3 would have to multiply by 4 to get 12. And then 1x would have to multiply by 1x to get 2x's. Now let's see if I did it correctly. If I did, I'll get this same first number. So a negative times a positive is a negative. 4 times 3 is 12. X times x is x squared. When I subtract this, I change the sign inside, turn it into addition. That cancels. Bring down everything else. Okay, what would I have to multiply 3x by to get 9x? This one's easier to see, but I'm still going to break it down. A positive times a positive would give me a positive. 3 times 3 would give me 9. And x times no more x's would give me 1x. So now multiply 3 times 3x is 9x. Subtract this. I get a 0. Bring down the other 0. How many times does 3x go into 0? Plus 0. So my answer in this case turns out to be 2x squared minus 4x plus 3, and I don't need to write the 0 down. So that's long division of a monomial into a trinomial. All right, since I don't think we can do too many examples, although I won't go past some, reasonable amount of time on the video, let's do another example like the first. So we want to divide x squared plus x minus 6, so that's one number, a trinomial, and we're going to divide that by x plus 3. So polynomial long division is the method we're doing. So I'm going to write my divisor, x plus 3, x squared. So let's make sure I have all my degrees. I have a 2, a 1, and a constant, a 0 degree. So I have all of my terms in my actual dividend. So I'm just going to write down what I have, x plus x squared plus x minus 6. And now do my division. Remember, just paying attention to the first two, to the term in the first, the term in the first place for both sides, and then letting the rest follow along for the ride. So what would I have to multiply x by to get x squared? Well, a positive and a positive would give me a positive. A 1 times 1, right, would give me 1. And x, there's 1x, I need one more x. So x times x equals x squared. Yay, I got the right number. And then x times 3 equals 3x. I have to subtract. That means change the signs inside and turn it into addition. X squared minus x squared cancels. X minus 3x is a negative 2x. Bring down the negative 6. Start again. What would I multiply x by to get negative 2x? Well, a positive and a negative is a negative. 1 times 2 is 2. And 1x times no more x's is 1x. So then do my multiplication. Negative 2x gave me my first term. Minus 2 times a positive 3 is a minus 6. Turn this into subtraction, or it is subtraction. Turn it into addition by changing the signs inside and turning it into addition. Negative 2x plus 2x cancels. Negative 6 plus 6 cancels. So this equals 0. So the answer is x minus 2. One more. This one is going to have a remainder. Just a little heads up for what happens sometimes. So this time I want to divide 3x squared plus 17x plus 13. And I'm going to divide that by 3x plus 2. All right, let's see what I have. Well, 3x plus 2 is my divisor. And by the way, it also has to have every degree representation, right? So I have a first degree, and then the next would be a 0 degree or the constant term. So I'm good to go there. And then on the inside, I need, check this out, I have a second degree and a first degree and a constant term. So I'm good to go there as well. I don't have to do any kind of rewriting with zeros. So 3x squared plus 17x plus 13. Okay, now let's do our division. What would I multiply 3x by to get 3x squared? You probably see already the answer to that question I just asked, but let's go through it step by step. A positive times a positive would give me a positive. Good. 3 times 1 would give me 3, so that would be a 1. I have 1x. I need one more x to have 2 x's. Okay, now do my multiplication. X, and I'm going to erase this one because it's just in the way. I put it there to make a point, but I don't need it anymore. So x times 3x is 3x squareds, and then x times 2 is plus 2x. I have to subtract this whole number, which means change all the signs inside and turn it into addition. 3x squared minus 3x squared is 0. 17 minus 2x is 15x plus 13, bringing down the 13. Now, what do I have to do to multiply 3x by to get 15x? Well, a positive times a positive is a positive. 3 times 5 is 15, and 1x times no more x's is 1x. Okay, I think I'm good. 5 times 3x is 15x. 5 times 2 is 10. Subtracting this number, which means distribute the negative sign, change all the signs inside, and add. 15x minus 15x, 0. 13 minus 10 equals 3. Nothing else to bring down. Next question. What can I multiply 3x by to get 3? Well, there's nothing, because I can say a positive and a positive equals 3. Or excuse me, a positive and a positive is a positive, and 3 times 1 equals 3. But x, I have 1x. What can I do to 1x to end up with 0 x's? There's nothing I can really do here. I mean, you might be seeing some tricky things like divide by x, but that's all crazy. There's nothing I can do to convert 3x into 3, which means that 3 is a remainder. So the answer to this question then is x plus 5 plus a remainder of 3. And we're going to learn how to handle this remainder much later, not in the polynomials unit, but later in the rational numbers unit. Suffice it now to say that you're good enough, if you get to a remainder, to just make a comment that you have a remainder. So that's dividing polynomials, a polynomial by a polynomial, which means now we have all 4 operations for polynomials. We can add and subtract, we can multiply, and now we can divide.